Friends, welcome to this video. Today we will be discussing about conjoint analysis. Conjoint analysis is a multivariate technique and is commonly used in business research for the designing of new products. Conjoint analysis is used for when we want to design a product which has multiple attributes and they are to be compared or combined together to get the ultimate product, and it is a decision which is to be taken regarding what shall be the combination of the different attributes. This is a survey based statistical technique, and then it is obviously a multivariate technique. This technique is extensively used for designing products in marketing and also in behavioral finance. So these are the two fields in which it is extensively used. The products or services that are to be designed has multiple attributes, and this is to find out that how people give value to different attributes of the product and services which is to be designed, and this is accordingly its help is taken when we want to place a new product in the market. We directly start with an example. Here we think of a mobile company that is going to develop a smartphone, and before it is done, it can actually launch the new phone. It has different combinations. Before it, the RAM, there are three options of RAM. It can be have a RAM of 2 gigabyte or 3 gigabyte or 4 gigabyte. Color can be gray, black and white. Memory can be 16 GB, 32 GB, 64 GB and 128 GB. And price can be measured in rupees, can be below 10,000, 10,000 to 15,000, above 15,000. So these are the different options that are available. If you take into consideration all possible options generating from these generating from the different attributes, so we find that it is 3 into 3 into 4 into 3, that is equal to 108 a number of possible combinations. So obviously it is a very Herculean task for the company to decide which combinations are possible or which combinations will give better results. In this regard, they want to have a look at all these possibilities and accordingly reach to a particular decision. Uh, Conjoint analysis can be done in an SPSS, as it is a multivariate technique involving a lot of observations and variables. So obviously the computation cannot be done manually, but we need to take the help of different statistical software with the help of which this conjoint analysis can be performed. One such software which supports conjoint analysis is statistical package for social sciences, SPSS. From most of the versions starting from 10, this 10.0 to the current version 26.0, conjoint analysis is supported in SPSS. So let us have a look at how we are going to combine these attributes in SPSS and how to reach to find out the best possible combination for the company. So first we need to create the design. That is, we are going to create the possibilities that can be actually generated from the combination of different attributes. So first we come to data, and then we come to orthogonal design, and then we click on generate. This helps us to randomly generate some of the combinations possibilities. But first we name the factors. So first we name the factor, and as you know that one factor was color, so we give the different options in color. So we press add, and then this color comes in the rectangle below. But there is a question mark, that is what are the different options of color that are yet to be loaded, that will take up one by one. Next option comes is in this way we write RAM and then click add. So RAM comes in the box below, then we write memory, click add, then memory comes in the rectangle below, and then we click write price, and then we click on add, so that the price comes under the in the rectangle below. So these we have named the different attributes. Now we'll try to include the different options that are available under the different attributes. So what we do is that we click on color, and once again, so as soon as we click on color, this color comes here once again, and then we click on define values, which is below this. So when we click on define values, then we get a form like this, and we can write it from here that we have options like one is gray, second value is for black, and third value is for white. As you could recall, or also I have place this by the side that there are three color options. So these three color options are written here, and then we press on continue. Once we press on continue, you can see that color now is no longer, there is a question mark in the bracket, unlike the others, but it has taken up the different values under color. Next we click on RAM, and then we click on define values. So once again we reach in this form, and now let us look at RAM. There are two options, 2, 3 and 4. So serial number 1 is 2, serial number 2 is 3, and serial number 3 is 4 GB RAM. And we can fill it up from 1 to 3. We can write it here also, 1 to 3, that there will be 3 options. And then we click on continue, and we get RAM, and these are the values. In this way we continue, and we get memory, the options, and the price, 3 options like less than 10,000, 10,000. Once these options are available and all the attributes and the options under each attribute is available with us in this form, now next we click here to create a new data set and give it a small name, which this small name, because we need to call it later in the later part in SPSS. So if the name is small, it is easier to type and there is less chance of error. So that is the only reason. After doing this, we click on options. Now once we click on options, then we actually land up with these, that number of cases to generate. Now this is not a full orthogonal design. That means we won't have all the options, 108 options, but we ask the computer to randomly generate some number of possible combinations for the product. So when we do this, and then we click on continue, and then we find that there is a plan is successfully generated with 16 cards. So we have asked for 10, but the computer is good enough to produce 16 combinations, and then it will be appearing in that data window. And this is the what you are seeing, that is the orthogonal plan that is coming up in the output. So we may skip out from here and go to the data window. Once we go to the data window, we'll find that under variable view, already some variables are identified. So color, RAM, memory, price, these are the 4 variables, and then status, and then card. So these are 2 new variables which are designed, which are actually produced by SPSS. So what are these variables and what are the values? For that we need to go back to the database. So we see that this status is all 0 and cards are 1, 2, 3. So cards appears to be the serial number, and status means whether this combination has passed or not, that we don't know. So initially it starts with the 0. So this has the if you are seeing this, these are all possible codes. So if we want to come back from the codes and decode them as per the options that we had in hand, so we click in this particular button, and as soon as we do this, we find these are the possible combinations. So you see this first font is called gray, means not called gray, color is gray. Its RAM is 2 GB RAM, 16 GB memory, and less than 10,000. So this is card number 1. You may save the data set in your favorite location, giving a small name, preferably in my documents, because we need to call this database. So already the data is named as conjoint, this data, this file. So you may save it in my documents or documents, whatever you have in the computer. So it will be easier for us to call the data set. Otherwise we have to write the entire path. But if it is the documents is the default location, so if we save the thing file in documents, so we need not write the entire path when you call this database, because we have to write a script for this. It is not, conjoint analysis is not available under the analyze menu, which we generally do in SPSS. So we have to write a script for that. Okay, now these are the 4 sets of values that are generated. All combinations are not there. 16 possible combinations are there. Now what the this is this here under status we have 3 options: see, design, holdout, and simulation. Design option is the combination shall be utilized to getting the preference from the respondent. It shall participate in the analysis. So when the code is like design, then that means the combination is will participate in the selection process, participate in the analysis. Holdout means the combination may be given to the respondent for use, but shall not participate in the analysis. That means it may be a possible combination, but it will not come in the competition. And simulation means shall not participate in analysis but shall be treated as a simulated combination. So this will be, so we actually go with design because that is what we want them to do this. So these are the possible combinations. Now what happens, the company might not be interested in some of the combinations because that may not be profitable or that may not be possible also. For example, gray phone with 2 GB RAM, 16 GB and less than 10,000. You see, this has already appeared before. Gray 2, 16 GB, less than 10,000 and design. So this combination is not taken because it is already there. Similarly, there might be some duplicates like this is another gray 2 GB and 126 GB RAM greater than 15,000. So this is already there. So or some may be dropped also because of the reason, not duplicacy, but because of the reason that the company doesn't find any reason for developing that. For example, this is a white phone which is a 4 GB RAM and with 16 GB memory. This is not generally offered, 4 GB 16 GB. So this is not a possible combination. If it's 4 GB, its memory space should be more like 128 or 64. But with 16 GB memory space and 4 GB RAM, no, this is not done. Company is not interested to produce such a foolish combination. So like this, some combinations are dropped from the entire setup. And so now it has taken away 6, as you can see, and we have these two uh, combinations which you may by looking at this, if you see, looking at the data set using your experience, like black phone 4 GB 128 GB, this will have a price of more than 15,000. So this may be a combination which you feel that is not there. Actually black 4 GB is there, black 4 GB, black 4, this is 2 GB. Now it's a black 4 GB is not there. And then we have gray 3 GB 64 GB and less than 10,000. This is a good configuration, but the price is less, so this may be preferred by the it means this combination may be preferred by the customers. So the company may want to put it up, but it is not there. So in such cases, we'll introduce this. We'll take away those things which we see are not important or which has got duplicated. So in this way, we will change the total number from 16. It may go down to 10 and then increase by 2. Anyways, so we ultimately end up with getting these few selections of forms, and we want to put these into tests. Yeah. So what we do is that the company develops 10 such fonts. First font is a gray font with 2 GB RAM, 16 GB memory, less price less than 10,000. So it is low configuration mobile. Price is also less. Then we have a gray 3 GB, 16 GB less than 10,000. And then we have a black 3 GB, 16 GB between 10,000 to 15,000. So like this we have a gray 3 GB, 64 GB greater than 15,000, black 4 GB 128 GB greater than 15,000. So these are high priced phones. So we the company actually develops 10 such phones, and as you can see, these are the 10 such phones. 5 of them are gray, 2 are white in color, 3 are black, and the configuration, other than the color, the configuration is written in its body. So and then it gives to a customer, say a customer like me, and it tells that you use these phones and give us the feedback by ranking them, which one you find is most preferable, most user friendly, or most responsive, etc. What are your parameters as per your understanding? You do this. So this person goes ahead and puts one to this particular phone, which is 2 GB 16 GB was less than 10,000, because the price is very less, so the configuration is not very high. And this way he gives rank to all the different phones after using it for some time. So we have this, as you can see, as per his understanding or his technical knowledge, or as per the response that he got on using them, these particular things were ranked, and accordingly we have a set of ranks like starting from 1 and going up to 10. Now this way the phone was given to different customers. These are the customers ID. We have here 18 customers, and these are the preferences. Preference 1, preference 2. This is the phone actually. And this is the preference 1, preference 2. This is the preferences. And so this customer, what he has done, he has found that the phone number 5 is most preferred. Then serial number 6 number phone is secondly preferred, third phone means 10th phone is third preferred, second phone is fourth preferred. Like this, the first phone is getting ninth preference. So these are all the preference level of all these phones. So this is how we get the preference level of the phones here. After getting the preference level of the phones, then we have the data set now ready for analysis. So as I discussed that unfortunately this is a particular type of analysis, conjoint analysis, which is not available under the analyze menu of SPSS. So there is no way in which we can do this analysis in SPSS. So as you can see, we come to file, we go to new and we click on syntax, because this since it is not available in analyze menu, under analyze menu. So what we need to do is that we need to do some computations. We write to now write some syntax, and with the help of the syntax, conjoint analysis will be performed. So once we click on syntax, we actually reach to a new window, and then in that window we write this, and that's why I asked you to keep a small file name. So this is the path that I am writing: C users and documents, and then conjoint and .sab. Sab is the name of the database. Then data, we tell the data is available in this one. We had a data set. This is saved in this, and then conjoint plan will come up in this. This is the output, and then I have a different file name from where it will take the data. And subject is customer ID, and performance 1 to performance 10. This is the sequence from where it will get the data. And then there are factors. Factors, we have color as discrete, RAM as linear, more. That means more the RAM, the better is the phone. So that's why linear more. Memory, higher the memory space, better is the phone. So it is linear more. And then price, it is linear less. That means lesser the price of the product, better will be the preference of the individuals. So this is lesser, price is less, and then we write print summary only. So this is the only thing we require to write in the syntax. And once we do this, after the writing is finished, then we select all these commands, and then we click on run selection. So once we click on run selection, or we click this, this is the run selection, and this is the tooltip text available with this particular button. When you keep your cursor in this button, this is what you get. This is called as run selection. So you click here, and accordingly you get this type of thing. So this gives an estimate of utility. That means out of the three colors, utility is maximum with white. Out of the three combinations, utility is maximum with 4 GB RAM. It's obvious. Out of the four combinations of memory, the utility is maximum with the 128 GB RAM. And price, here you see price, nobody is liking to pay the price because the utility is negative with each of them. But out of which the least negative is this. So people are preferring to pay less than 10,000, though even they are not ready to pay 10,000, they want it, the things in free. Anyway, so this is the combination, and then these are the importance values, which one is more important. So you see out of these, the maximum importance is with the RAM, followed by memory, and then with the price. So these are averaged values across all the reference data set. Now this gives us the coefficients of RAM, memory, and price. We will get the coefficients only against those values which are linear in form, not against those values which are like color, which is not, as you can see, this your color is discrete. So against discrete values you will not get anything, but against linear values, numerical values are there. So corresponding to that, you get the coefficient estimates. And this also tells me that price is something negative, indicating that higher the price, less will be the utility associated with it. And there are a correlation between this correlation between observed and estimated preferences. So correlation between observed and estimated preferences are quite high, and they are significant. That means the model has justified the data from on which it is built. And then we have got something like this, that we just put these things. This is actually how do we get this, because this we do with the help of a linear combination. So we have, you see this color gray, then it is minus 1.61. Uh, so you see this here, color gray minus 1.61, and RAM, if it is, we have these values, say 2 GB RAM, then it is 2.146. So this is a 2 GB RAM, 2.146. Then it is a, you see, this is 16 GB memory, 1.217. So 1.217. So what you can do is that you can take this data set in Excel, and these values you can take in Excel. These values you can take in Excel, and then using a VLOOKUP function, you can have these values, or else you need to type them in. Look at the value of gray and look at the corresponding table, that is this table, utility table, and write the utility value of gray. You go into this next RAM, whatever be the RAM, look at the utility value, write it there. Look at the memory value of that particular fast combination, whatever is the memory value corresponding to that, what is the utility, you write here. And the price, whatever be the price, you look at the price and write the price utility corresponding to price here, and then you actually sum them up to get this total score. So this is the total utility of the product available from here. This way, for each of the combinations, we search from the utility table and get the corresponding values. So what I prefer to do is that we have to go on with a particular, go to an Excel file, write the possible combinations that we have, 10 possible combinations, and then also in another part of this page we can write the utility table, and then using a VLOOKUP function we can actually to look at this, and from the utility table by the side it will pick up and place the value. So that way also we can do, that will make the work short, and then just we add up this. So we see the utility corresponding to preference 1, utility corresponding to preference 2, utility corresponding to preference 3, like this we get the values. After we get the values, now we actually looking at these values, we rank them. That is, we found that this is the maximum rank, so 1. Next value is this is having rank 2. Next value is this is having rank 3. Like this we have these different types of ranks. So these are the ranks that we have corresponding to the different values, and then we actually that's the end of conjoint analysis. Now what we have to do is the report the result of conjoint analysis. So we write it like this: the conjoint analysis is performed to find out the most preferable combination of color, RAM, memory, and price combination in case of smartphones. There are 3 possible color combinations, 3 possible RAM values, 4 possible memory values, and 3 category of prices. Instead of using full factorial experiment 108, we designed the experiment with 10 combinations dictated by the availability of the product and market requirement. So we dictate these are the whatever the market requirement is there, and the product availability. Certain product might not be physically or means possible, or maybe absurd also in certain cases. Once the combinations are decided upon, they were sent to 21 respondents for their preferences. Their preferences in terms of ranks were recorded and were put to analysis in SPSS. Next, to estimate the utility of each of the options under color, RAM, memory, and price were obtained, placed in table 1, say. The importance values, table 2 tells us that the RAM is the most important factor, followed by price, memory, and color. As we had seen in table 2 that the values were ranked as per their importance. The correlation between the observed and the estimated preferences is high and significant. This indicates that conjoint analysis has done justice to the data. On using the estimates of utility from table 1, we evaluate the aggregate utility, aggregate means total, of the different smartphones, and find that the white phone with 3 GB RAM, 128 GB memory space, having price below 10,000 is the most preferred, followed by gray phone with 4 GB RAM, 64 GB memory space, and having a price range from 10,000 to 15,000. So this is the report of the analysis, and based, if it is a real live analysis, then based on this study, a company can actually produce the smartphone. So actually in the smartphone there might be several other features. So all these features we could include in the phones, and then we can have similar type of analysis. Now, if you want to read more about conjoint analysis, you may actually read this particular two texts. One is Marketing Research and Applied Orientation by Naresh Malhotra and Satyabhushan Das. And then we can also look at this Vittal Rao Applied Conjoint Analysis. So this actually describes how the thing is to be done and how one should proceed. Thanking you for watching this video. Have a nice day.